So this video is about routing in .NET Core MVC. So let's start out with a question. So let's say that some user entered a URL or clicked a link with the URL. Some URL is sent to the server. Now the question is, how is it decided which action to run, or in general, which code to run? You see, a URL is usually not thought of as a path to a file on the server. It's more like a recipe for finding a piece of code. Okay, and the answer to this is in very general, that the routing mechanism determines this. We simply have a concept called a routing mechanism, and that's really what decides this. Okay, and this is a very general concept. It has different implementations, like for instance, in an Express server written in JavaScript, it'll work differently. Okay, but we're going to look at how this takes place in .NET. Okay, so let's take a look at what a URL is. So it has a host, possibly a port, and then it has what Microsoft calls segments here. Segment 1, segment 2, /segment, all kinds of, well, there could be many segments here. Okay, and the point here is that the host, the IP and the port decides which IP to send to and which process application on that server. And the rest here, all the segments, they decide which action to invoke. Okay, so, and this can of course be set up in a way. If you have tried MVC, you will know that the usual way to call an action is to write the server : the port /controller / the action. And that's, well, it is a convention, but it's something that you can change, something that was coded. Okay, so all the routing information is usually in program.cs. When we talk about something called conventional routing, it has been located elsewhere in previous versions. You have to get used to the fact that these things change with newer versions. And so you might find older articles describing it differently than it works now. So you just have to live with that. Anyway, the conventional routing takes place with something like this. So this should be written in program.cs, and this is just an example of the default routing that you were given. So this is, you don't have to write this. This is given from the beginning. And I'll show you, I just made an application here. Well, I didn't just make it, I added some things as you can see, but this part of program CS, which is right down here at the bottom, has this piece of code, and I did not write this code. What comes later, I wrote. We're going to take a look at that, but right now, I just have this default conventional routing. And you might be able to see why it's called a conventional routing. It's because it defines a convention on how routes should be understood. And it says that the first segment should be the controller, the second segment should be the action. And what happens is that this is a pattern, and given a URL, the .NET framework will try to locate a rule that where the URL matches the pattern. So to match this pattern, you need first a segment defining the controller, then a segment defining the action. And if it matches that, then the controller will be set equal to the first segment. It will simply try to locate a class with that name without writing controller. And the second segment will try to find will cause it to try to find an action in that controller with a name that was written. So let's take a look at some examples of this. So here's a URL, search this, server, port, and this is /student/all. So this will map to, this will try to find a controller that is called student controller and has an action that's called all, and try to run that. So this maps to the action all in the student controller class. So now if I do not write the action, it will use the default here. This is the default value for action. If action is not specified, it'll use index. So this one will map to the action index in student controller. If I do not write anything at all, it'll also use the default value for controller, which is home. So this will be home index. So the action index in home controller. And note again, you don't have to write controller. Okay. So what will this do? This will map to the student controller, the find student action, and then this one will match the third segment, which is not required. It's optional. But if you write anything as a third segment, it will assign that to this variable. And if the find student has a parameter named ID, then that parameter will get the value 5. Okay, let's see how that works. So I have a student controller, and we'll have to abstract from all those. So here's a find student method. It has an ID parameter, which is necessary to match this. It has to have the same name. And so if I run this and then use this, then hopefully we will hit this action with the right value in the ID parameter. So man, I'm unable to remember that. Find student /5. Okay, and see what is the value of ID? It's 5. So this works. What if I don't enter anything? Then ID is just default value 0. Okay. If I write Bob here, I'm going to be in trouble. Yeah, so it still matches it, but it figures, well, there is no ID. There's no int, because Bob can never be converted to an int. So it'll just still be 0. Okay. So that's good. Or at least that's how this default routing rule works. And you can use this. You can hit any action in your application using this. The only one problem is that you can only have one parameter, and it has to be called ID. Otherwise, it will not be automatically populated. So maybe you want to have other rules for other actions that requires more parameters. Okay, let's see what else we can do. So we can have static elements. So here's a pattern called students/show. You'll notice that there's no controller. There aren't any variables here. It's just students / show all. This will only match the URL students / show all. And it can only map to one action, which is student index. Okay. This is called a dedicated conventional route. It's called dedicated because it's dedicated to a single action. Maybe it's a lousy thing to call it a conventional route because there's no convention in this. It's just one action is mapped by this. But it's called a dedicated conventional route because it uses this convention-based syntax. So if you were to do this and not use this default or some other more generic route, you'd have to write one of these rules for every action you have. This could be tough. And I guess that's why you have these generic routes instead. Okay. So why is this a good thing? Because if you want to rename your controller, let's say you only use this, and someone somewhere has made a bookmark to your URL. Let's say they made a bookmark to student / all, or student / find student / 5. Then if you rename your controller, it's not going to work anymore. The bookmark is going to be dead. Or if you move your action from one controller to another controller, it's not going to work either. You'd have to contact everyone that uses your URL and tell them to change it. Potentially millions of people. Whereas if you use this structure, you can change it just here. You still catch the URL, and you can just change here that the controller is different, or the action is different, or both are different. Okay. So this is how default routing works, and you have to be a little careful about this. I will show you an example later, but if you have more of these, they will tend to, they might overlap. You have to be careful with this. The system will choose the first one that matches. So so it could be a problem. Okay. Another thing that you could do, I'll just show you this very short. You can of course add something. If you don't want to have this, you might, for instance, say, "Oh, I'm going to use this is an application about courses and students." So you might call it course app / controller equals home. Now, what happens now? Does anything work? No, it doesn't. Why not? Because this is not matched. This URL is no longer matched by this because it has to start with this. And this is a static. This is a constant. It's not a variable. So you have to put this, and then it'll work. Because now it says this, and controller is missing, thus the default, and action and this missing, thus the default. If I want to use the find student, let's write, what was it? Students / find student / 6 maybe. and that does not work. Let's see what was wrong about that. Ah, it should be student, not students. Let's see. Okay, and the ID is 6, and we're all happy. Okay, so this is, you can control your URLs like that. Okay, so there's another way to do this. One that will give you more control, but it will also force you to type more. And that is called attribute-based routing. And it works like this. You use attributes on your actions. And the attribute is called root. It can also be on your class. But for now, let's take a look at assigning a root attribute to an action. What is the student details? Let us see, student controller, student details. There. Okay, we have to stop it. Because right now, student details is not going to do anything good to us. But I can do this. And then this one hits precisely the this action. Better copy paste it. That was not good. See, these results. Yeah. Well, I should have put a breakpoint here, but see, it hits this one. Okay. So this way you get a more fine-grained control over what you're doing. This is annoying because this does not follow my naming scheme, which was course app at the beginning. See, so I would like to have course app and then student details, but that's not going to work because which route is this going to match? It's not going to match this because this does not start with course app. So it's not going to match this. So what's it going to try to do? It's going to try to match. This is the only other one we have. So it will try to match this, and then it's going to look for a controller, I guess. Yeah, and it didn't find, there's no controller called student details. Student details controller, so it's not going to work. Yeah, so what can we do about this? So I could put course app on this one. There you go. And then student details. Okay, got to restart it. Takes a little while. Course app / student details. Yes, okay, there you go. Now we can get something nice working here with controlling how the URLs should be. And I can rename this if I want to, or I can even move this to a different class. I have a course controller. I can move it to the home controller, for instance. Okay, work fine, no problem. Silly place to put it though. I think I'll put it in the course controller. Yeah, let's see. It should still work, I hope. Slash course app slash student details. Okay. Yeah. Well, I didn't. I don't have the. I need to move the view. My view, the details. This view is here, so I need to move that to course here. I'm going to do that, but that will work. It just couldn't find the view, but it hit this line anyway. Let's just move it back to my student controller. There you go. Okay, so, but being able to refactor your code is probably a good thing. You could argue that your student controller should really define the interface to your application and say that once I put this here, it should stay here. And then the implementation could go elsewhere. That's one way of defining how the interface should be. This is another way of defining how the interface should be. You simply say that this is the interface, and you're not going to hit these. You're not going to attack this by writing controller/action. You're going to hit it using this route, and thus this defines the interface of your application. By the interface of your application, I mean which URLs are going to do what. And now you can define this using, you can define it for each method you have. And you're free to change the name of the method later on. This is all that matters for the outside world. Okay, so let's see what we can do with this. So first of all, this gives a more precise control of the mapping. And the second thing is you can create complex rules. Now suppose that I want to find all the students on my on a given course. It has a course ID, and I want to use a URL that says course, starts with course, the literal course, and then I want to write the user to write the course ID and then /students. This is one way of defining URLs. This is probably more common when you're using APIs than when you're using regular Razor pages. But still, if you want this way of writing your URL, you can write this route like this with attribute-based routing, but you cannot do that with conventional-based routing. So let's see if I have an example of that. Here it is. It says this route. And yeah, I don't know why it says courses here. I probably thought that these should all be prefixed with courses. Like you might want this to be prefixed with students. So find your naming. I find your own naming way. So, but let's see how this works. Students on course. So I should type courses, course ID, students. I can never remember that. Let's run the damn thing. Okay, and course ID is a variable. delete this, maybe course 9, and it hits here, right? And course ID is 9. Okay, and then you can do whatever you want. I'm not sure I even have a view for this, so I better just stop it. But the point is you're getting the course ID here from this URL. So that's one nice thing you can do with these. It can be mixed with conventional routing, and that's what is done here. And the rule is that if an action, if an endpoint has an attribute-based routing, then it will not be hit by conventional routing. And I'd actually like to show you a little about what is going on behind the scenes. So you can get a list of endpoints. This is more or less how the system matches the URL to the endpoint. For instance, here's a route here. It maps to this action here in the course controller. It has an order of 1 or 0. Those are the most important ones. Attribute-based routes are always order 0 unless you change it. You can change it. And then you see all of these conventional based routes. Here you can see this route could map to course controller.index or to course controller.details or but I think you won't be able to find students on course here. See, it's only up here. Nowhere else. So students on course can no longer be bound by this route. So attribute-based routing takes precedence, you could say. And so this way you can use attribute-based routing for most of it and then have a default route for the rest of it. So you can use attributes, the root attribute, also on classes. And let's see why is that. This is because this is really annoying. First of all, okay, this is courses, right? I want courses here, and actually I want this. Where is it? Course app. Of course, it has to start with course app. Course app / courses. See the problem? This is horrible. How can I get rid of? How can I ever escape this? Course app, courses, details, and an ID. Oh my God. Let's see if this works. Oh, I have to run this first. So /this /3, what is that? Details for, yes. And, damn. That's strange. I didn't get the right value. Wow. But we hit the right action. Only the automatic mapping didn't work. Why is that? See, it has to match the name, right? Okay. So let's try it again. Let's hope it works now. ID has a value of 3. Okay, great. So now I have to type all these places. This is terrible. This is, I don't know. I don't want to do this. I want to do that on top here instead. Okay, and let's see if it works now. Now I have to remove it here because what this is going to do is it's going to prepend this root with this root. And to be honest, I'm not sure whether I need the slash here or not. So let's just try and remove it. I think I probably don't, but you never know. Let's see. Ah, there you go. Correct value. It works. It hits the right action. Okay. So now you have a more manageable system, right? You can just put in the root name here in front of all of your actions, and you can use this syntax or this way of structuring your URLs, and you don't have to write this more than once at the top, and you can change it easily. Okay, so final thing, constraints. So you can put constraints on these. So let's try and do this. First, we're going to try it with convention based. So let's go down here. I think I didn't show you how to do this, but I think I showed you in, yeah, okay. So if I do more than one of these, I should find unique names. It's not going to complain about it. It used to in previous versions. It doesn't now, but do it, because otherwise other things that I'm not going to go into today might get fucked up. Okay, so I have a pattern here, students. Should I use? Yeah, I'll just take this. Students find ID, and I'm going to call an action called find student. And where is that? In the student controller, find student here. Here it is. And yeah, I'm going to get an int in there. And yeah, student, find student. So I just need to use this. Five. Did I put a breakpoint? Yes, I did. Okay, ID is 5, all is well. And find student 5, and I'm going to write Bob instead, which is not an int. So now it doesn't accept this. So what happens is I put in this root constraint here. If I remove this, let's see, like that. Oh, got to restart it. It works in the end. And what about Bob? Now it works, but Bob obviously isn't an int, so it's never transferred to the parameter. So this is what constraints do. But you should notice what happened. So not 8, Bob. You get a 404. This is not a very nice way of telling the user that they should have written an int instead of a name. I mean, this could be caused. You'll get the same error if you write an X here, right? Same error. Or if you write the wrong port. I think. Yeah. Same error. No, actually not. There's no one is listening to that port. Okay, but if I write the wrong anything, you'll always get a 404. It's not very, it doesn't communicate anything to you except that you did something wrong. So what you can say is that you should not use constraints validations. 404 is not a very friendly response. What you should use them for is to distinguish actions. And I'm going to show you what I mean by that. There's a certain problem here. So let's comment in this one also. So find student by ID, find student by name. I have a name here instead. It's still the student class controller. It's still find student action. And now I have another constraint here. It's called an alpha root constraint. Now the alpha root constraint is disjoint with the int root constraint in the sense that they can never both be fulfilled, because int obviously needs to be an int, and alpha root constraint is only fulfilled if it's not an int. If there's one character in this segment that is not an int, so it has to have something that is an alphanumeric character except the ints. So they obviously is disjoint. They cannot both be true. So this is nice. And why do I want this rule? Because I have this. Okay, find student by name, find student by ID, but they're both called find student. Now, notice that this is not a problem for .NET or for Java or any other sensible language, because these are just two overloads. If you call this method, the compiler will look at what actual parameter you're sending, and it'll decide which of these to call. And if it's in any doubt, you cannot compile. But this is not really the situation we're in right now. We're in the situation where somebody writes a URL and you have to figure out which student, which action to call. And notice that the action in the action is no mention of which of the two. There's no mention of the parameters here. Yeah, this is one. But let's see if this works. So student /find/for. See what this does. Okay, it's unable to. No, I don't know. In my opinion, it might be able to figure it out using the constraints. I mean, that's the point of it. But apparently, it's not able to do that when we have this conventional based. mapping. It would work fine if I just rename this, find student by name. Just put in a breakpoint. And then adding this. And remember, this is not going to affect the URL at all. The URL is still students find and then something. Okay, so students find 4. Let's see what that does. Now the ID is 4 and everything is working as supposed to do. And what if I say Bob instead? It matches this one instead. Okay, name Bob. And we're all happy. Okay, so I didn't have the view. The view should be called find student by name. I could just write find student here. Now it will work. Okay. So, but this, at least I haven't been able to make this work this way. There might be a way to do it. But we do have the other option. There. And let's remove this one also. And go to student controller. So you could say about this that the constraints were able to distinguish the two situations where you write an int and where you write something that is definitely not an int. It's just that you have to have a different name here. But the constraints work in a way, it's just that this root is unable to distinguish between the two actions. Now, if we do it like this instead, it will be able to distinguish. Notice that if you do attribute-based routing, you write the constraints differently. Okay. You can find a list of all of these. This is like 20 or 25 different different constraints, and you can use them both in the conventional and in the attribute-based routes. They just have different names. You can find lists of them. If you Google, it's very easy to find a list of those and all kinds of stuff. Constraints that define that you need to fulfill a certain minimum length or a certain maximum length, or all kinds you need to be, that an int need to be an interval. You have regular expressions also. So, and you can make your own. But it needs to be written differently here. So we have students. Is that the same that I wrote? Find. I think I'm just going to write find. Okay. Students find. Yes. Okay. And name. Okay. Now let's do it again. -6. And we find student by ID. And Bob is find student by name instead. And it would work all, I should have changed the names so that they're identical. Otherwise, you're not going to believe me. So students find Bob, and the two actions have the same name, but it's still able to distinguish them. Okay, great. And now it works again because my view is called find student. So yes, attribute-based roots and constraints, and that was the show. Thank you very much for listening.